Hello everybody, welcome to Sane Game Studios. I'm Zane, I'm an amateur game developer. Today on Gamemaker for Beginners, we're going to be taking a look at the basic collision functions. I was going to do all of the collision functions, but I realized pretty quickly that it was just going to balloon into way too big of a video, so we're just going to cover the basic ones today, and then I'll have another video coming out soon that's going to cover more complicated, more advanced collision functions. So there are a lot of different ways to categorize collision functions. The way that I categorize them is I categorize them in three. There's ones that return a boolean, which is true or false, so whether or not you are or are not colliding with something. There are ones that return an ID, which will not tell you whether or not you're colliding with something, but if you are colliding with something, it's going to tell you what exactly you are colliding with, the instance ID of that object. And then finally, there's the hybrids, which are collisions that do return an ID, but in code, you can write them as if it's a boolean. Gamemaker and the GML, the Gamemaker language, is very flexible this way, and these functions are really, really handy because you can use them for pretty much anything. So with that, we can just jump into things. I only have two objects. I have a player object and a wall object. My wall object, as normal, has no code. It just exists. And then I have a player object. And it just has some basic top-down movement code. If you don't understand what this code is, or you don't know how to do top-down movement code, I already have a video on my channel that explains all of that, and you can go ahead and find that video and watch it. Actually, I'll put a link to it in the description down below. I also have a single room set up, and it just looks like this. And if I run it right now, you're going to see I'm going to be able to move, but I won't be able to collide with my walls. So today we're going to be looking at collision functions and different ways that we can collide with these walls. So the first one that we're going to be looking at is actually going to be place empty. So place empty is a Boolean function. It's going to return either true or false. It will return true if the area that you were looking at does not have the object you want to look for, and it's going to return false if the area does have an object that you want to look for. So this is not generally how I would do collisions, but just to show you guys how exactly this works, I'm going to go down here to where I'm updating my X and Y position, and I am just going to very simply just go if place empty X, Y, O wall. And then here I'm going to say X plus my HSP, and down here I'm going to say Y plus my VSP. And what this is going to do is it's going to check if the place I am looking at currently has an instance of O wall in it. So the place I'm about to be moving to, if it has an instance of O wall. And if it does not have an instance of O wall, then I'm actually going to do my movement. So one thing that's actually kind of nifty about this is that it's going to use the collision mask. So it's going to use the bounding box of the player. So like if I look here, look at collision mask, you can see my collision mask encapsulates the entire sprite. So it's actually going to use my collision mask with the player, and it's going to compare that to the collision mask of the wall, which is also its entire sprite. And so it's going to see if at its next move, if the collision masks overlap, and if they don't overlap, then it's going to move. But if it does overlap, then it's not going to move. So if I run this right now, you're going to see exactly what that looks like. See, I cannot walk through the walls anymore. So that's essentially what place meeting is going to do. It's going to look at a specific instance that you feed it, and then it's also going to look at the exact coordinates that you tell it to look at. Here I'm going to be looking at my next movement. And if this instance does exist, then this is going to return a 0, a false, because that place is not empty. But if that instance does not exist at this location, then it's going to return true because it is empty. So, but here I'm saying, if this is true, move. And that is how I am using this collision function. So the next one we're going to be looking at is place free. So what place free does is you don't actually have to feed it an object for it to look for. It's going to look at all of the objects at any given position. And if that instance is flagged as solid, and if you watch my introduction to objects video, you'll know exactly what I'm talking about when I say flagged as solid, then it will consider it collidable and it will collide using this function. So to explain what solid is, if I go to my wall object, right here in the object editor where it says solid, if I tick this to true, then it is solid. So then I can go back to my player step event, and I'm actually going to say if not place free x plus HSP y, and then I'm going to say that my HSP is going to equal 0. Okay, so what exactly is happening here? So place free is going to return a boolean, it's going to return a true or false. And if there is not an object at the position that I've given it that is flagged to solid, then it is going to return true because that place is free. Whereas if there is an object, it's going to return false, which is what this does. This exclamation point right here would be the same thing as me saying if it equals false. And so if it is false, that means that the place is not free. That means I do not want to move. So I'm going to set my horizontal speed to 0. I'm going to do the exact same thing, but instead of HSP, I'm going to do my VSP. And that's going to give me the ability to collide with objects that I have flagged as solid. See, I'm able to collide with them just fine. This is not the best way to do this. This is a good way to do it if you want to use the solid flag for your collisions, but this is not the best way to do collisions in my opinion. So the next one that we're going to be doing is place meeting. And if you have watched any of my tutorial videos, you would have seen place meeting. Place meeting is going to be the bread and butter of your collision functions, at least for the sake of movement. When it comes to movement collisions, place meeting, in my opinion, is the GOAT. It is the best function for figuring out whether or not you are colliding with something. And it is actually rather simple. What it's going to do is it's going to return a boolean, a true or false, and it's going to be looking at the collision mask of the player versus the collision mask of the object that you want to collide with. In this instance, it's going to be a wall. And if you are going to collide with it, it's going to return a true, and if you are not going to collide with it, it's going to return a false. So what I'm going to do is I'm going to say if place meeting x plus HSP y wall, then my HSP is going to equal 0. I'm going to do the exact same thing for my vertical speed. So what I am doing is I am taking a look at this coordinate, which is the coordinate that I wish to move to in the next frame, and I'm going to see whether or not there is an instance of wall in that coordinate. And if there is, this is going to return true, but if there isn't, it's going to return false. So if there is not an object for me to collide with, then this code will not execute. But if there is an object for me to collide with, then this is going to return false, and this will execute, which means that my horizontal speed will be zeroed. So if I run this now, you see that I can collide just fine. So the next ones that we're going to be getting into is position empty, position meeting, position destroy, and then finally position change. So the reason why I've grouped these together here is because of this word right here, position. So position is not going to be using the bounding box. It's going to be using the bounding box of the wall, but it's going to be using the actual origin point of the player. So your every object is going to have a very specific X and Y coordinate. So my player is, it's 32 by 32, I believe. 64 by 64. So my player is going to be at, let's say X32 and Y32. That is going to be its position, but it is actually 64 pixels wide and 64 pixels high. So when my origin, which is in the center of my sprite, when my player is at 32 and 32, then the top corner of my player is going to be at 0, 0, and the bottom corner of my player is going to be at 64, 64. Position meeting is going to ignore the collision mask, so it's going to ignore the 0, 0 point, the 64, 64 point, and it's only going to look at the very specific coordinate of 32, 32. So it is not great for doing movement collisions. It does have its use, don't get me wrong, but it is not going to be great for using movement collisions. But I'm going to be showing you guys how this works with movement collisions, and it will actually demonstrate why it's not the greatest. So the first one we're going to look at is position empty. So position empty is going to work pretty much the same way as place empty, with a couple major differences. The first major difference is going to be the fact that it's not going to use the collision mask of the player. It's only going to use its origin, but it will use the collision mask of the object that I wish to collide with. The next thing that makes it different is that it's actually not going to be looking for a very specific instance. It is going to just a very general look for any instances that it can collide with. It's not seeing whether or not there is a specific instance somewhere. It is seeing whether or not that position is empty. So here I'm going to say if not position empty, x plus HSP y, HSP is going to equal 0. I'm going to do the exact same thing again, but for my vertical speed. And I'm pretty sure that when I run this game, I won't be able to move at all. Yep, cannot move at all. And there is a very simple reason for that. My player is what's making the position not empty. So it is looking at the origin of the player, and then it's looking at my speed in comparison to it. So let's just take a quick second. Let's open up the create event, and my speed is 5. So if I look at my player sprite, look at my collision mask. So right here, this is my origin at 32, 32. And let's say I want to move 5 pixels to the right. So I'm going to go 1, 2, 3, 4, 5. It's very approximate. That is not actually 5 pixels. But the point is that point that I'm looking at is still within the collision mask of my player, which means that I cannot move because my player is making the position not empty. So if I change my collision mask to just be a single pixel right at the right in the middle there, I all of a sudden will be able to move. And then I can collide with the walls. But I'm going to overlap with the walls to my origin point because it is ignoring the collision mask of the player. It is seeing whether or not the exact position at my X and Y coordinate is empty. Position empty does have its uses. Probably the main thing that I would use it for would be for object spawning. If I wanted to spawn an object at a specific location, I'm going to see whether or not that position is empty. And then if that position is empty, I'm probably going to spawn the object and then immediately do a place meeting check. And if it passes the place meeting check, then I know that where I've spawned it is not only empty, but everywhere that the object is drawn is also empty. And then if it passes the place meeting check, I'm just going to go ahead and continue with what it is I want to do. Whereas if it doesn't pass that place meeting check, then I'm going to destroy that instance and try to spawn it somewhere else. So the next one we're going to be looking at is position meeting, which is the same thing as position empty. The only difference is it's going to see whether or not you are meeting at that position. So position meeting. Another major difference that this has between position empty and position meeting is empty is checking to see whether or not any instance exists at that location, whereas position meeting is simply going to look for a very specific instance. And I can use this the same way that I use place meeting. The only difference with this and place meeting is that this is not going to use my collision mask for the player, but it only uses the origin. So I can actually write this the same way that I would write my place meeting check. And then I'm just going to copy and paste this from my vertical axis. Then if I run this now, you're going to see I'm going to be able to collide with the walls pretty much the exact same as it was before. But due to the fact that my player itself is not going to interfere with this, then I actually consider this a better way to check this. So I prefer position meeting over position empty, but both of them absolutely have their use cases. So the next one we're going to be looking at is position destroy. So what I'm actually going to do here is I'm going to set it so that I can click and destroy things. So position destroy isn't a normal collision function. It's not going to return a true or false. It's not going to return an ID. It is simply just going to destroy whatever it is that you're interacting with. So I'm going to say if mouse check button pressed, MV left, position destroy, mouse X, mouse Y. So what this is going to do is I'm going to click the left button on my mouse and it is going to destroy whatever it is at the position of my mouse. So here I have my game, and if I click on this wall, it's gone. Click on this wall, it's gone. Click on the player, it's gone. It's because I'm just destroying those objects. So position destroy absolutely has its use cases. I would say it's more useful for like RTS games and stuff like this. You can absolutely do a object check before you destroy it. So like let's say you want to destroy a villager and you have like an object named O Villager. You would see if the mouse button has been checked. If the mouse button has been checked and the instance that it is looking at is an O Villager, you can destroy it in that position. For the types of games that I make, that's probably not something that I'm really going to use. I'm not saying those games are bad, I'm just saying that I just personally have no interest in making them. So the next one is position change, and I do not recommend that you use this function at all. It has actually been flagged as depreciated, which means that Gamemaker also recommends that you do not use this function at all. The only reason that this function has not been deleted from the Gamemaker archive is because Gamemaker is very supporting of what they call legacy projects. So if you are creating a project that you started in a Gamemaker that had position change as a valid option for a function that you could use, and you are still working on that project, Gamemaker does not want to make your project no longer work because it decides to remove a function. Gamemaker does have a whole bunch of what they call depreciated functions, and they are exactly that. They are functions that Gamemaker is no longer supporting and actually recommends that you do not use, and they keep them in there purely for legacy reasons. That being said, position change is one of the most ridiculous functions I've ever come across. This thing is crazy. So what I'm actually going to do is, you know what, I'm just going to leave position change like that, and I'm going to go X, Y, O player, true. And before I explain exactly what's happening, I'm just going to show you guys what this does. As you can see, it turns my walls into players. There is a whole bunch of reasons why I can think of that this would absolutely break a game. but I could see how in certain games it might be helpful, thinking about like merge games maybe, or like let's say you have a merge game and you have a bomb that's going to turn all of the tiles in a certain area red. You can absolutely use this to change all those tiles red and make them like the red blocks instead of like the blue blocks or the green blocks or whatever. But that's very edge case, not something I would recommend using, and not something that Gamemaker recommends using. So a position change is going to take 4 arguments. It's going to take a position in which to change and a Y in which to change. It is then going to ask for an object that you wish to change that object into, and then it's going to ask for a true or false argument, and that is going to be whether or not you want that object to perform the create event of the object it's being turned into. So like if I flag this as false, the walls would become a player, but they would not run the create event, and they would not have very necessary variables in order to do what it is that I need them to do. Like it wouldn't have walk speed programmed into it, for example. So it's going to take any object at this position, turn it into this object, and then if you flag this true, it is also going to run the create event for this object while it converts. It's honestly dangerous, and I consider this function playing with fire, and I think I am validated in thinking that by the fact that Gamemaker does not recommend this function. And I honestly did not know this function existed until I went to make this video, and it honestly kind of blew my mind a little bit. Do not use this function. And now we have the final couple that we're going to be looking at. So we're going to be looking at instance place and instance place list. So this actually is rather useful. It's going to use the collision mass, same way that like a place meeting check would. And the only real difference is that instead of just a true or false, it's going to return the ID, and you can use that for a whole bunch of things. And I'm going to show you guys a good example of what you can do with instance place. And this is honestly how I did my semi-solid platforms in my semi-solid platform video. If you want to learn how to do semi-solid platforms, I'll put a link to that in the description down below. But I'm actually going to go back to my wall object. I'm going to go to my variable definitions. I'm going to create a new variable, and I'm going to call it collidable. And I'm going to set this to be a Boolean, and it's going to default to false. I am then going to go to my room, and I'm going to check this. I'm going to go to its variables, and I'm going to set this wall's collidable variable to true. So this wall right here, its collidable is true, and this one is false. And we're going to make it so we can collide with this one and not this one. And we're going to do that using instance place. So the first thing I'm going to do is I'm actually going to create a local variable, and I'm going to call it call for collidable, and it's going to equal no one. And then here, I'm going to say that call equals instance place x plus HSP y o wall. And then I'm going to say if call does not equal no one, which means that it has found something here. Because if it looks in this position and there is no instance of OWall in that position, then this function is actually going to return the value of no one and store it in this variable. So if it does not equal no one, I'm going to grab its ID, which is stored inside of that variable, and I'm going to look at its collidable variable. And if it equals true, my HSP is going to equal 0. And then I'm going to reset call to equal no one. Next, I'm going to do pretty much the exact same thing. The only difference is I'm going to be doing my vertical axis. So then if I run this now, see, I can collide with this one. Oh. Typo. Alright, so if I run this now, you can see I can collide with this wall and not this wall. That's because one of them is flagged as collidable and one is not. So the next one we're going to be looking at is instance place list. So it is going to be doing the exact same thing as instance place with one major difference. It is going to be able to look at more than one instance. So let's say I have multiple walls that overlap each other and they're all going in different directions, and I'm trying to butt up to the intersection where multiple of them intersect. What instance place list is going to look at a specific position, it's going to look at the object in which you want to collide with, and it is going to see how many of them exist in that position, and then it is going to store them inside of a list. And I'm going to be using this to create pretty much the exact same effect that we had before. I'm going to be writing a bunch of code here, so I'm just going to skip over it, and then we'll go over it together once I'm done. Okay, so as you can see, I wrote a good amount of code here. So what exactly is happening? The first thing I'm doing is I'm creating a local variable and I'm calling it list, and I'm creating a DS list. That stands for data structure, and it is just pretty much an array. Then before I did anything else, I actually went to the bottom and I destroyed that list. And the main reason why I have to destroy that list is because I'm creating a list and storing its location in memory in this variable, and then this variable is going to be forgotten at the end of every frame, and then every single frame I'm going to be creating this variable again and a new list. But at the end of the frame, when this variable gets destroyed, this list does not get destroyed. I just lose any form of a variable pointing to it. So I actually need to destroy that list, otherwise every single frame is going to create a new list, and that is going to create a memory leak, which will eventually lead to loss of frame rate, so it'll cause your game to lag and eventually crash. You don't want memory leaks. So to prevent the memory leak, as soon as I was done with the list, I destroyed it. And actually, not even as soon as I was done with the list. As soon as I wrote this line, and then I put spaces in between them, and I wrote all of this in between those two lines. So the next thing I'm doing is I'm creating another local variable, and I'm calling it found. And what I'm storing in it is a little bit complicated. So instance place list does exactly what I said. It's going to take this position, it is going to look for instances of a wall, and it is going to store them in this list in no particular order. But what this function also does is it is going to return the amount of instances that it found. So the amount of instances found is going to be stored inside of the variable found. So if I found one instance of a wall, that one instance is going to be placed on this list, and found is going to equal 1. So if found is greater than 0, which means that I have found something, the instance place list function found a wall and has stored it in the list, and it has found at least one of them, and I have a wall in that list to interact with. So if found is greater than 0, I'm going to create a for loop so that I can use the variable found, because that is going to be the length of my list, and I can just loop through that entire list regardless of its size, and then I can grab the ID of any instance that is on that list at any given position, and then I can see whether or not it is collidable, and if it is collidable, set my horizontal speed to 0. And then I'm going to clear the list so that that list is empty when I go to do my vertical functions. And then I am doing the exact same thing here. I am just seeing how many I've collided with, seeing whether or not I've collided with any, looping through any instance that exists inside of that list, seeing whether or not it's collidable, and if it is, I am instead setting my vertical speed to 0. So if you don't know what a for loop is, that is fine. I've gotten a request lately to do a video on loops and the different types of loops, and I will be doing a video on loops so you can understand what they are. They are very useful, and once you understand how to use them, they are one of the greatest tools you can have. So with that, I'm going to be able to collide with these walls no problem. Well, this wall. The other one's not flagged as collidable, so I can go right through it. And that is how you can use instance place lists. So there are actually 2 more functions, but I'm not going to explain them because there has been enough information in this video for you guys to know what they do. And that is instance position and instance position list. And they are going to work very much the same way as instance place and instance place list. The only difference is instead of using place, which is going to be the overall collision mask of the player, and instead it's going to use the position, which is going to be the actual origin of the player, and it's going to ignore the player's collision mask and only look at the collision mask of the object in which I am referencing in the function. Other than that, it's going to work the exact same way. You are, instead of getting a true or false value, you're going to get a instance ID in which you can then look at its properties. But that is all that I wanted to go over today. That is just some basic Gamemaker collision functions. Stay tuned. Next week I'll have another video on more advanced collision functions. I'm going to thank you guys very much for watching. If you're interested in those videos that I mentioned earlier, there are links to them in the description down below. If you have any questions about what I've done here today, you go ahead and comment those. I will absolutely go out of my way to try to help you. If you have any tutorial requests you would like to see, you can also comment those down below, or you can go to my community page on my channel, and I do have a couple posts there that ask for tutorial ideas. You can go ahead and comment those there. Other than that, I'm going to thank you guys very much for watching. I hope to see you guys next time. Please like, comment, and subscribe, and peace out.